All right, so this is the Unit 2 quiz. So first we'll start with number 1. Function g of x is x minus 3 quantity squared, plus 5 is a transformation of the parent function f of x equals x squared. Which of the following statements are true? Select all that apply. So we got to check all of them. So first it looks like a and b are related. G is the result of f being translated right 3 units and up 5 units. This one says left 3 units and up 5 units. So I'm really just deciding if I'm moving left or right and just double checking that I am going up 5. So first we can check that we are going up 5. That is true because we do have a plus 5 on the end. So the k value makes it go up 5. So remember this is k, which I guess I should do that in green, but that's all right. We'll switch it. We'll make it green. I also got to find out the other terms. So I got to find a and h. So this one is k. So h is over here. So we have to remember that h is 3, which means we're going to go to the right 3. So since we're going to go to the right 3, we definitely want to pick this one, which means we're picking a out of these two options. Now there's no number in front here, so remember 1 is going to be a. And it looks like I have to pick between either c or d. The graph of the function f opens upward. The graph of the function f opens downward. Since a is positive, we're going to open up. So we can't open down because a is positive. If it was open down, then a would have to be negative. Lastly, it says the graph of the function f is compressed horizontally by a factor of 3 or vertically by a factor of 3. Well, if we're compressed vertically by a factor of 3, we would need a to be 3, but a is not 3, so we can't pick this one. If we wanted to be compressed horizontally by a factor of 3, we would need a 3 inside here. So it would have to be 3 times x, which we don't have that either. So we're not going to pick either of those. Even though it looks like it should be pick one of the two, neither of the two is true, and that's possible. So it's only going to be a and c for number 1. For number 2, we have to find the domain and the range of the function. It's a parabola. We can see we've got a squared here. So we know that the domain is always the same. The domain is always negative infinity to infinity, which if we wrote it out in words, it would be all real numbers. So it's not going to be either of those ones. Since we know that 1/2, since a is positive, we know that the form for the range has to be from k out to positive infinity. So that means I need my numbers to be bigger than or equal to k. This one is a less than or equal to. This one's a greater than or equal to. So because a is positive, I know I can pick the one that has the greater than or equal to. And then just so we double check, k actually is -7. So yeah, -7 to infinity is the range. Which, if we write it as an inequality, that would be all numbers that are -7 or bigger. All right, for 3, what is the equation in vertex form of a parabola with vertex 1, 2 that passes through 2, 5? So we see here we want to get the equation, and we have the vertex. So that tells me right away we want to write down the vertex form equation. Y equals a parentheses x minus h squared plus k. We're given the vertex. We know what h is. We know what k is. So we're going to plug them in. So we have to plug them in just like we did in class. Y equals a, x minus 1 squared, and then plus 2. All right. So next we see, hey, we have a point that we also have. So for our point, we have to remember that that's x and y. So we're going to plug these in for x and y. So y is -5. We still don't know a because we said in class the goal is to try and figure out what a is. We've got 2 minus 1 squared plus 2. We're going to say we want to move k to the other side, so we'll subtract 2 from both sides to get -7 equals a. And then 2 minus 1 is going to be 1 squared. Well, 1 squared is 1, so that's not too bad. So -7 equals a, the first time, times 1. I could divide both sides by 1. I really don't need to. It's pretty clear that a is going to be -7 in this case. So what we need to do is take our -7 for a and then plug it back in right there. So when we plug it back in, we'll get y equals -7 x minus 1 squared plus 2. And since it says it wants it in vertex form, we're done. We don't need to convert it. We don't need to multiply anything. We're just done at that point because that is vertex form. All right, for 4, write the equation in the form y equals a parentheses x minus h squared plus k of the parabola shown in the graph. So again, it's telling us that we want to use vertex form, so we just have to know, okay, vertex form it is. We need to find the vertex, but they give us the vertex. It's labeled here. So we know that this is going to be h, and we know that this is going to be k. So just like the last one, I can go ahead and just throw those in. So we've got y equals a parentheses x minus squared. H is -1. K is -6. We'll clean it up a little bit. Y equals a x squared minus 6, and this will be a +1. All right, so again, same deal. We're trying to figure out what a is. The whole goal is to figure out what a is. But we need to go and we need to grab another point somewhere on the curve. And we can pick any point that we want. It just has to be a point that we can see hits the intersection of 2 of the lines. So if I want, I could pick this point up here. That would be the point 1, 2. I'll pick that one because that looks like it hits the line. It looks like it crosses the line here. Let's see what happens when we plug that one in. So we get 2 for y. So let me label this again as x and then y. So 2 is y equals a parentheses 1 plus 1 squared minus 6. I guess that should be a blue one. All right, same deal. We move the 6 over. We add 6 to both sides. So we get 8 equals a. And then 1 plus 1 is going to be 2. So 2 squared. Since 2 squared is 4, 8 is going to equal a times 4. We divide both sides by 4 to get 2 equals a. So we're going to plug this back in again. We'll plug it into this equation right here to get a final of y equals 2 x plus 1 squared minus 6. And if we want to double check, we can totally double check this. So we know we've got h and k right. H is -1, k is 6. There is a way to check a. So if we go up 2 and over 1, we should hit the first point on the parabola. So you can check it that way. You can grab it that way, but sometimes it's hard to see, and especially if it's going to be a fraction, you can't really tell that way what fraction would be because it's tough to tell between 1/3 and 1/4, for example. But that's one way that sometimes you can check if you get a whole number. So since we went up 2 and over 1, that makes sense. The first slope is 2. The next slope is going to be much more than 2, but the first slope is 2. So that does make sense. For part B, it says write the equation in the form y equals ax squared plus bx plus c. So now what we want to do is we want to actually expand this. So I'm going to rewrite this as 2x plus 1 times x plus 1 minus 6. Now there's a whole bunch of ways that we could choose to multiply this. I think I'm going to go just the way where I'm going to take my constant out front and plug it in and distribute it inside one of the 2 parentheses at first. Again, there's a ton of ways to do this. I'm going to stick with the double distributive property just because I did a distribute right here. So that would be 2x times x plus 1 plus 2 times x plus 1 minus 6. All right, well, I'm still distributing because for the double distributive property, I need to double distribute. So I'm going to distribute once. 2x squared plus 2x. I'm going to distribute again. 2x plus 2, and my minus 6 is still hanging out over here. I'm going to combine my like terms at the end, so 2x and 2x is going to be 4x. 2 minus 6 is minus 4, and I've got an answer. So I want to check my graph to make sure it makes sense, and it does because the y-intercept's at -4. So at least my -4, at least my value for C makes sense. Now, how could I double check to make sure I got the right answer? Well, we could throw it in the Desmos. So we got 2x plus 1 minus 6. So 2 parentheses x plus 1 squared minus 6. And that, well, that does look a lot like the graph that we were given in the initial thing. Our vertex is at -1, -6. Y-intercept's at 0, 4. But if I want to double check the other one, we had 2x squared plus 4x minus 4. And we can see that the blue curve exactly overlaps the red one. So we know that they're the same, and we said that the red one kind of looked like the picture, so I think we're good to go. I think I'm pretty happy with the result that we got. So again, never hurts to double check, but that's one way that you can double check to make sure that you do get the right answer. All right, for number 5, it looks like it's kind of the same thing. G is a transform of the parent function f of x equals x squared. The graph of G is a translation right 2 units and down 4 units of f. What's the equation of G written in the form of y equals a x minus h squared plus k? So all of our transforms are given to us, but we notice we didn't really get any stretches. We're not vertically reflecting. So a is going to end up being 1 in this case. X squared. H is how far we go left or right. If we're going right 2 units, that means that h has to be -2. Because minus, if we put 2 into the original formula, if we put 2 in here, we would get 2 units to the right, x minus 2. For k, we have to go down 4 units, so that means we have to put in -4 for k. And we're actually done. That's it. That's all we have to do. You don't actually need the 1, so if you really wanted to, you could rewrite it as y equals x minus 2 squared minus 4, but both are totally fine. For part B, it says, what's the equation in standard form here? Y equals ax squared plus bx plus c. Since I did the double distributive in the other one, I'm just going to go ahead and do the area model here for this one. So x minus 2 squared would be x squared minus 2x minus 2x and then 4. So I get x squared minus 4x plus 4, and then I still have this minus 4 over here. So minus 4. I combine minus 2 and minus 2 to make minus 4. And at the end, x squared minus 4x, well, minus 0 plus 0. I don't even need that because these ones are going to cancel out when I combine these like terms. Okay, that makes sense. Again, just want to double check. So we want to double check to see if we get the same thing for both graphs. So I'm going to graph each of them. So x minus 2. You can see I don't really need to change the format of the equation. Minus 4. Over here, I also don't need to change the format of the equation. We had minus 4x. And again, yeah, those look like they're the same. So I'm pretty happy that I did the algebra correctly. If I check at my vertex down here, it looks like I'm going to the right 2 and down 4, which is what the question asked for. So I feel like that's pretty good. I feel like I'm pretty confident with number 5. For 6, what's the vertex of the graph of the function f of x equals x squared plus 6x? For this one, we want to use the equation x equals negative b over 2a. So we want to find the axis of symmetry because that's going to be the x coordinate. So I'm either going to get 0, -3, or 3 because those are the only options I got in the choices. So let's plug them in. So we have to remember that a, well, let's do that in red again. A is going to be 1 because it's a number in front of the x squared. B is going to be 6 because it's the number in front of the x. So negative 6 over 2 times 1. Well, negative 6 over 2 times 1 is negative 3. And at this point, I can just pick A because that's the only one with negative 3 for the x coordinate. If I want to double check, again, I have to plug my negative 3, in for the two x's. So we'd have negative 3 squared plus 6 times negative 3. 9 plus negative 18, which is in fact negative 9. So this one does check out. So if I wanted to double check, I could. Again, it's another one that if I wasn't sure, totally good to plug it into Desmos. Let's turn this one off. We got 1x squared plus 6x. I'm going to scroll a little bit. But if I click down here, yeah, negative 3, negative 9 is the vertex. So I can double check that way too. So a lot of different ways that you can do these problems. For 7, which statements describe the key features of our function x squared plus 2x minus 8? Select all that apply. So again, we've got 1 for A. B is going to be 2. And then C over here is going to be negative 8. Well, the y-intercept's at C, so I know that A has to be correct because C is negative 8. For axis of symmetry, we're going to use the same equation as the last one. X equals negative B over 2A. So we get negative 2 over 2 times 1, which is negative 1. So I know this is not right because I got negative 1, not negative 9. These two both look promising. So the vertex is either 1, 9 or 1, negative 9, or possibly neither. But they both look promising. I can't get rid of either of the two options. I have to plug the 1 in, the negative 1 in. So we get negative 1 squared plus 2 times negative 1 minus 8. So that's 1 minus 2 minus 8. That's minus 10 plus 1 is minus 9. So the vertex is going to be at negative 1, negative 9. So I can pick that one. Again, I got negative 9, not positive 9, so I have to get rid of that choice. So the two I want to pick are A and D. Again, if we're stuck, we plop it in, we check out the graphical version. So we get x squared. I completely forgot what it was. X squared plus 2x minus 8. All right, so down here, the vertex is at negative 1, negative 9, and we can imagine our axis of symmetry. X equals negative 1. I'll make a dashed line as well. You can imagine our axis of symmetry. We kind of fold over that point. So we want the axis of symmetry to be negative 1, not 9. And down here, we can click on the x-intercept or the y-intercept also. So the y-intercept is 0, negative 8. So again, very good one to check, but convenient to do by hand. For number 8, pebbles tossed in the air from top of the cliff. Height of the pebble over time is modeled by this equation. So we got our negative 16, so it's our regular gravity equation. What's the maximum height in feet reached by the pebble? If we need a maximum, we're just going to go with negative b over 2a again, because that'll tell us where the x-coordinate of the vertex is. We could plug that in to get the y-coordinate of the vertex. So when we plug these in, we get negative 32, because again, this is b, this is a. We don't need c for this question, so I'm not going to label c yet. 2 times negative 16. Well, negative 32 over negative 32 is positive 1. So we know the x-coordinate is 1. All right, well, we need to get the y-coordinate now. So negative 16 times 1 squared plus 32 times 1 plus 50. It's negative 16 plus 32 plus 50. Well, that's 16 plus 50 is going to be 66. So I know the vertex is at 1, 66. But I'm not asked for the vertex. I'm asked for the maximum height. So I have to think, all right, which one is the x and which one is the y? And the y, it turns out, is going to be the height. Because it says the height of the pebble over time is modeled by the equation y equals. So the height is measured. So that tells me that the height is going to be the y. So I only want the height. So I'm going to get 66 feet. So that's going to be my height. Again, another one you can throw to Desmos. Negative 16x squared. We're using standard form, so negative 16x squared. 32x plus 50. We have to zoom out a little bit on this one. Well, maybe a lot. But we get a top up here at 1 comma 66, and that's exactly the vertex that we got from calculating. So that's kind of convenient that our calculations worked out. Oops. All right, cool. So number 9, what's the equation of the parabola? It passes through these 3 points. Again, tons of ways you can do this one. So we saw in class that you could do a system of equations. So using y equals a x squared plus bx plus c, we could set up the equation y equals, oops, we need a first. We can plug in for y because we know y. So for the first point, 2 equals a negative 2 squared plus b times negative 2 plus c. For the second point, we get 8 equals a times 1 squared plus b times 1 plus c. For the last equation, it would be 50 equals a times 4 squared plus b times 4 plus c. And we know if we want to use it as a matrix, we can go ahead and turn it into a matrix by saying negative 2 squared is 4. Well, I'll just write it. Yeah, I'll write it this way first. And then minus 2b, and then plus c equals 2. Here we've got 1a plus 1b plus c equals 8. And down here we've got 16a plus 4b plus c equals 50. So when we convert that to a matrix, 4 minus 2, 1, 1, 1, 1, 16, 4, 1, 2, 8, 50. And if we want, we can do an RREF for this. So that's one way that we can get all of our coefficients. The other way, and I think the way that I would prefer it, is let's just use the regression lines. So let's go ahead and make a table. And we want to put all of our points into the table. I do not remember the points. So negative 2, 2, 1, 8. I want to say like 450. Let me double check though. Yeah, 450. And we're going to go ahead and do the quadratic regression. So y1, again, this is much easier on the TI, but y1 tilde ax1 squared plus bx1 plus c. Okay, well, that's not too bad because it is standard form. We just got to remember the little ones after it. And it gives us our parameters. A is 2, B is 4, and C is 2. So 2, 4, 2. So that means that our equations should be y equals 2x squared plus 4x plus 2. Make sure I got the right order. A2, B4, C2. A2, B4, C2. All right. Let me move that down. And remind us that we're using y equals ax squared plus bx plus c. So we're still using standard form from up here. I got to bring up the matrix calculator. I forgot to bring up the matrix calculator. So we got to bring that up. There we go. So if we were to put this into the matrix, let's just double check because again, we've been doing things a lot of different ways. So just in case you prefer the matrix, let's see what it looks like. 4, negative 2, 1, 2, 1, 1, 1, 8, and 16, 4, 1, 50. All right, let's do an RREF on this one and matrix A. And you can see we get the same thing. So we get 2, 4, and 2. So we know that the first one, A, is 2. Second one, B, is 4. And the third one, Y, is 2. So we take the 2, 4, 2, and we do the exact same thing. So if we did it with the matrix or if we did it with the regression, we get the same answer. So again, It's your choice. Personally, I think the regression is a little bit easier because then I don't need to write any of the equations. But I know we had a lot of success with the matrices last unit. So if you really like the matrix, you can use the matrix as well. All right. For number 10, use quadratic regression to find the equation of a quadratic function that fits the given points. And this is really why I prefer the regression, because you have to do the regression here anyway. You may as well just do the regression once for number 9 and then just throw everything back into the regression for the next one. Because here we've got 0, 1, 2, and 3, 22, 42. $59, $36. I've already got my regression already typed in, so I just need to reread the numbers and then I'm already done. So let's just grab those just because I'm feeling a little bit lazy. We'll steal those, paste them in there, and then we still need to write our answer correctly. So I can't just write down A, B, and C. That would not be a correct answer because we do want the equation. So we're going to get y equals negative 10.75 x squared plus 38.15x plus 20.15. So you can remember the a gets the x squared, the b gets the x, and c is just the number. And that's literally it. We're done. It's just a calculator question. For number 11, we have to factor. So factor the expression 4x squared minus 11x minus 3. So we take our two numbers on the outside, 4 and negative 3. 4 times negative 3 is negative 12. I got to find things that multiply to negative 12 and then add up to the middle. So I have to add up to 11, negative 11. So the ones that I think are going to work out, the ones that I'm going to guess are going to be negative 12 and 1. Because negative 12 times 1 is negative 12. Negative 12 plus 1 is negative 11. So that works out. You could do the double distributive method if you want. I think I'm going to just stick with the area model here. The numbers I picked were 1 and negative 12. My two purple numbers are 4x squared, negative 3. GCF along the bottom. The only thing that's in common with those is x. And so then we have to just divide a whole bunch of times. So 4x squared divided by x is 4x. 1x divided by 1 is 1. Negative 3 divided by 1 is negative 3. So if I factor it, I'll end up at x minus 3 along the side, 4x plus 1 along the bottom, and we're all done. It doesn't matter how you do it. If you wanted to see it done with the double distributive method, I guess I'll do that one too. 4x squared minus 11x minus 3. So, all right. So we're doing the double distributive method. So 4x squared. We still get to keep that. We get our two blue terms. I'm going to pick plus 1x to go first. You know what? I'm going to pick minus 12 to go first. I picked minus 12 first. I'll be nice to minus 12x. So minus 12x because that was one of the numbers that I picked. And then plus 1x because that was the other number that I picked. And then minus 3 still on the end. So between each of my two sets, I have to find out what my greatest common factor is between each of them. So between 4x squared and negative 12x, I can divide those both by 4, and they both have x. I'm going to be left with just x. If I divide 4x squared divided by 4 is 1, x squared divided by x is x. Negative 12 divided by 4 is negative 3. X divided by x would be 1. On the other side, they don't have anything in common, so 1 is my greatest common factor. So that just gets left as is. So 1x divided by 1 is x. Negative 3 divided by 1 is negative 3. I check my parentheses are the same. So since my parentheses are the same, that tells me I did it correctly. I'm all good to go. Since these x minus 3s are the same, we get x minus 3. And then I take my leftovers and I put my leftovers together. 4x plus 1. So you can see we get the same answer either way. It doesn't matter which way you do it. If you want to double check, again, Desmos will let you double check it. So we got 4x squared, 11x, and 3. Let's turn this off. Let's turn my dots off. 4x squared minus 11x minus 3. And when we factored it, we got x minus 3 and 4x plus 1. And again, those two lines, they're the exact same. So I'm good to go. I don't really need to, I feel like I'm good again. If I really want to double check, I got 3, 0 and negative a fourth 0. And so if I plug this 3 in, I do get a 0 because 3 minus 3 is 0. So that's good. That works out. Negative 0.25. If I plug that in over here, 4 times negative 0.25 is negative 1. Negative 1 plus 0 is 0. So I got it that way too. So I can also do it right from the graph. A little bit tricky because, again, with the fractions, you're going to have to convert everything so that they do have these coefficients in front. But it is possible. You can just use the graph in order to do it. I think it's a little bit easier to factor it by hand, but it is possible. All right, for number 12, solve the equation. This is one I'm going to assume most people are going to say, well, I remember how to solve the equations from unit 1. I'm going to put 3x squared plus 3x in for y1. So that would be, turn that off, but 3x squared minus 3x in for y1. And I think we had y equals 60. We do the y equals just because that's what we do. And then we kind of zoom out and hopefully we get it. Looks like we got 2 points. We got 5 and negative 4. And I'm guessing most people are just going to say, you know what, I'm kind of happy with that. Just like those other ones that we solved in Unit 1, there's no y's, so you don't use the y coordinates. I think that's it. I think that's all we got to do. If you do want to do it out by hand, you're more than welcome to. To do that, we can divide everything by 3, so that's going to be nice. X squared plus x equals 20. Subtract 20 from both sides. So I get x squared plus x minus 20 equals 0. And now I can factor this. So again, I got to find things that multiply to negative 20 and add up to 1, because there's 1x right here. If I got to pick, I think I'm picking regular 5 times negative 4. 5 plus negative 4 is 1, so that works out. So my factors are going to be x plus 5, x minus 4. Remember, since this is just regular x squared, we can just skip to the answer right away with the 2 blue terms that we got. Now we got to be careful because remember this is still equal to 0, so we still get to use the zero product property and solve each of these. X plus 5 equals 0. Subtract 5 from both sides. X equals negative 5. X minus 4 equals 0. Add 4 to both sides. X equals 4. Did I get my signs right? Negative 4 and 5. Negative 4 and 5. Something looks a little bit off. What's a little bit off here? Let's see. We subtracted 20. We got 5. We got minus 4. Oh, that's what's wrong. I typed it into the graph wrong. That would help. Oops, not 0. This is a plus sign. Okay, now that changes things a little bit, but we still get negative 5 and 4. All right, we'll switch these around. And that's it. So it looks like we're good. So we match up. Again, so pretty easy to do with the graph, but I messed it up. So you got to watch out. You got to be careful. Because again, if you just do it like that and you mess it up, that's no credit. But if you show your steps over here as you kind of go through it, you will earn some partial credit even if things go awry. So this is a good way to check. But if I were to rely on it, I would have missed the question. So tread very carefully if you choose to do it with the graph. For 13, projectiles launched in the air, we've got this function, h of t is negative 16t squared plus 48t plus 160, gives the height h in feet of the projectile t seconds after it's launched. After how many seconds will it land back on the ground? So since we want to know when it'll land back on the ground, that's when we want to know when it's equal to 0. So we're going to set this thing equal to 0. So negative 16t squared plus 48t plus 160. And you're more than welcome to change these t's into x's if you'd rather have the x's. I see that I can divide all of these by 16, which seems very suspicious, so I'm going to do it. In fact, I'm going to divide everything by negative 16. The reason I want to do that is I want to get just t squared, or if you change them to x's, just x squared, because then I can use that factoring trick where if I just figure out the numbers, I can just write down the two factors right away. 48 divided by 16 is 3, and then 16 and 160 will give me 10. All right, so I need to factor this. So again, I need to find things that multiply to negative 10 and add up to negative 3. Well, there's two convenient ones, which would be 5 and negative 2. 5 plus negative 2 is 3. That works out. So since I made t just by itself, I automatically know I'm going to get t plus 5 and t minus 2. Again, this still does equal 0, so we have to be careful, but we can solve each of these with the zero product property. Subtract 5 on both sides, so t is equal to negative 5, which, if we're thinking about it, that doesn't make sense in the context of the problem. We can't really have a negative time. We can add 2 to both sides, though, and get t equals 2, and I'm pretty happy with that. I want to double check myself. Again, it's always worth it to double check, so I'm going to throw it into Desmos. Negative 16t squared. And again, I'm going to make these x's instead of t's. And also, I'm going to make this a negative sign, not an equal sign. Let's see, what else we have? 48 plus 48 and plus 160. Again, I want to find the zeros, so hopefully I did it right. I got negative 2 and 5. All right, so what did I do? I did something wrong again. Oh, the signs are getting me today. So let's double check here. We got t squared minus 3. Oh, there's my issue. That's why it's good to double check. I wanted to get negative 3, not positive 3. So I messed up the signs this time by hand. So always good to double check. All right, so if we change those, that's not too bad. We just need this to be negative 5. Well, let's just put an x on that one because that one didn't work. My first guess was wrong. Negative 5 times 2. Negative 5 plus 2 is equal to negative 3. So that's what we want. So instead of plus 5 and minus 2, we want minus 5 and plus 2. And so I got to change all of my signs. That's a little annoying. But again, that's why it's worth it just to double check. T minus 5 equals 0. Add 5 to both sides, we get 5. T plus 2 equals 0. Subtract 2 on both sides, we get t equals negative 2. And now this one doesn't make sense. Again, we don't want to get a negative time. We want a positive time. So we end up at 5, which I guess I don't need a plus 5 over here. Just 5 is good enough. So 5 seconds. Again, you can double check it with the graph. You can use the graph. Check your work. Not too bad. If the numbers are scary, again, we see that GCF division trick. But there we go. All right, for 14, identify the intervals which y equals x squared plus 9x plus 18 is positive. So what we want to do is we want to find the zeros and then make a sign chart. So let's factor this thing. So again, I got to find things that multiply to 18 and add up to 9. All right, well, this is 6 and 3. Oops, I'll do that in blue. So hopefully I did that right. 6 plus 3 is going to be 9. And again, if I didn't, that's fine. We just try again. So 6 plus 3 is 9. Looks good. So we'll factor it. So we get y equals x plus 6, x plus 3. All right, so since I want to do a sign chart, the first thing we do is identify where the zeros are. X plus 6, x plus 3. So we can use the zero product property again. Subtract 6 on both sides to get x equals negative 6. Use the zero product property again. Subtract 3 on both sides, get x equals negative 3. And now we get to do the sign chart. And I think the sign chart's really cool. So let's see what happens when we use the sign chart. what we want to do is we've got one at -6. We've got one at -3. And I have to pick numbers on all three sections. So I'm going to pick something that's bigger than -3, less than -6, and something in the middle. Well, my favorite is to find 0 and just find out where 0 would go. So 0 is over here, because that's going to be the easiest. We plug 0 into the original equation, and we're going to get 18. 18 is a positive number. I don't really care that it's 18. I only care that it's positive. I also like 10. So -10 is going to be my next choice. So again, the reason I like 10 is if I plug 10 in here, it's like just doing base 10. It's like just counting, because 10 squared is 100. -10 times 9 is 90. That's 18. Well, 118 is bigger than 90, so I know that this is positive. The last one, though, it's a little bit tricky, because now I have to pick something between -6 and -3, and I'm kind of out of numbers that I really like to pick. So I just have to pick maybe -5. Maybe that one will be nice. Now I could come up here and plug it into the original, or if I want, I can plug it into this blue equation. There's no rule that says I can't just plug it in here and do -5 plus 6 times -5 plus 3. Because this is just 1 times -2. That's easy to do. That's positive times negative is negative. So I just have to use that as my sign rule. I don't even need to figure out what number it is. I can just use the multiplication. So I've got my sign chart, and now I need to interpret my sign chart. So this one asks when it's positive. So I need to give the regions that have the plus signs. Well, that's the side with the -10, which is going to be -infinity until we get to -6. And I'm also going to get the section with the 0. So from -3 all the way back out to positive infinity. So that's really cool. I like the sign chart. But this is another one where if the sign chart is a little bit tricky, you can check yourself with Desmos. We got x squared plus 9x plus 18. Here we go. X squared plus 9x plus 18. And yeah, so if we remember back from unit 1, it's like, okay, so as we go from left to right, it's going to go -infinity to -6 is positive because it's above the x-axis, and then also -3 out to infinity. So the graph does match up. So we can tell we did the sign chart correctly. But I just think the sign chart's so cool, so I'm just going to use the sign chart. For 15, and this is the last one, right? Yeah, okay, cool. Write the equation of a parabola with x-intercepts -1, 0, and 3, 0 that passes through the point 1, -8 in the form y equals a times the quantity x minus p times x minus q. So remember, p and q here are the two x-intercepts. So I can go ahead and label those as p and q because they're the two things that are the x-intercepts. We have our point over here. We have x, y. So we really have everything that we need to plug in. We're still trying to figure out what a is. Just like when we did the vertex form, the goal is to figure out a. So y is -8. A we don't know, but we know literally everything else. 1 minus -1, 1 minus 3. We'll do the two parentheses. 1 minus -1 is 1 plus 1, which is 2. 1 minus 3 is -2. 2 times -2 is -4. We divide both sides by -4. And so we get 2 equals a. So now we know a, and now we're basically done. Final answer is going to be y equals 2, because 2 is a. X's stay as x's. Minus -1 is the same as +1, so I'm just going to write +1. And then -3. And that's it. That's my answer. Again, if I want to double check, I 100% can just use Desmos to double check it out. So we've got 2x plus 1, x minus 3. I need a new one. Equals 2x minus 1 plus 1, x minus 3. I'll get this blue one off. So that's what I'm claiming I want the answer to be. So I have to check to make sure it passes through all the points it says that I should pass through. So 3, 0 and negative 1, 0 are my intercepts. That checks out. That's what I want. And I need the point 1 comma negative 8. So let's see. If x is 1, see where that intersects, because it's not always going to be the bottom. I could give any point. But yeah, 1, negative 8 does check out. So I go through that point as well. So I'm pretty happy. I'm pretty happy with that. I got it. Now this is a little bit tricky because I did specifically ask for this form. If I didn't ask for this form, what I could do is I could just go ahead and sneak it over here and say, well, you know what I want to do? I'm given the points 1, negative 1, 0. I'm given the point 3, 0. And I'm given the point 1, comma 8. So I think I'm just going to go ahead and let the calculator do it and get a nice little equation over here. Because I could do this as a regression because I'm given 3 points. If I wanted to, I could just sneak it. But is that helpful here? Not particularly. Because what am I going to do with this information? Well, with this information, I can write the equation y equals negative 2, which that doesn't seem right. 1, 8, 1, negative 8. So my a value should match up, and I like my a value from before. All right, there we go. Let's re-sneak this. So I made another typo. That's like 3 mistakes for this one already. But that's all right. None of them count because I caught them all before I stopped. So they're all good. So y equals positive 2. X squared minus 4x minus 6. And here's my issue. In order to get it into the form that I'm asking for, I have to factor that. And chances are, if you're not willing to do this, you're probably not willing to factor either. But just so we can see how that's done, we can see that they have a greatest common factor of 2. So I can divide them all by 2. So that's going to be x squared minus 2x minus 3. And then I have to think of things that multiply to negative 3 and add up to negative 2. Well, that's going to be minus 3 times 1, because negative 3 plus 1 is negative 2. So we get y equals 2. We picked minus 3, and then we picked plus 1. So you can see I do get the same answer. I'm allowed to switch the order of my parentheses. That doesn't really matter. But I think that's going to be a little bit extra work. I guess if you really don't like plugging things into the equation that you're given on the test and you really want to factor, you can. There's no rule against it. You're more than welcome to do that. But yeah, either way it does work out. So whichever way you feel more comfortable with, go for it. Personally, I think that's a little bit too much work, but it works. You can do it. Whatever you're most comfortable with. So that's everything from the quiz review. This one's pretty long just because I kind of showed how to do almost all the questions more than one way, whether it's more than one way by hand or by hand and then with the Desmos. So that's why this video was a little bit longer than the quiz is probably going to be. All right.